All right, good morning, everybody. Today we are going to be evaluating trig functions using that unit circle that we generated in the last video. Now, it says using the unit circle, which means calculator is going to be off limits except for checking. But since we will be using it for checking, just to take note, if you hit the mode button, on some of these problems, you'll want to be in radians, like if you see a pi, and in other of the problems, you'll want to be in degrees if you see the degree symbol. So we're going to be using our calculator to check ourselves, but you're going to see why we can't use our calculator to purely find all of these answers, because some of our answers are going to be radical answers, like that negative radical 3/2, which means to find it exactly, we have to use the unit circle. So let's go ahead and start with number one. We are looking for the sine of 315 degrees. So remember, sine of an angle means we are looking for the y part of the coordinate. So I'm just going to write a little y by number one. So we're going to go to 315 degrees. So we're rotating to that angle, 315 degrees. And the y part of that coordinate is negative rad 2 over 2. Negative rad 2 over 2. Now, if I were going to try to use my calculator on this problem, and we are already in degrees, what we would find is that sine of 315 is, oh, that terrible looking decimal. So this is not great because for our answer, we would have to first round this, which, yeah, if we could get the exact answer, that would be a lot better. There's no way my calculator can convert this into that radical form. So if you try to do the good old math, enter, enter, it still is going to stay as that non-terminating, non-repeating decimal. But we can use our calculator to check ourselves. So if I actually type in this radical expression, negative rad 2 divided by 2, well, you can see, oh, it's equal to that same nasty little decimal. So you can use your calculator to check yourself, but on most of these problems, we are going to need to purely use our unit circle to find those exact radical answers. So let's go ahead and look at number 2. Now, on number 2, we are looking for the cosine of negative 210. There's two ways to approach this problem. The first is to visualize what that negative angle looks like. So this is what we were kind of talking about in the first page of the notes. So if I rotated to 210 degrees, that would be in quadrant 3. If I rotated that same amount in the negative direction instead of the positive direction, so if instead of going this way to 210, I rotated down by that same wedge amount, that would take me to 150 degrees. So this is actually equal to the cosine of 150 degrees. So some students like that visual way of thinking about rotating to that angle. Positive, remember, is up from the x-axis. Negative is down from the x-axis. But we can also find this positive coterminal angle by adding 360. So I would just put a note by this one that yes, you can visualize it, or you can find the positive coterminal angle. And we can do that by simply adding 360. We add one full rotation around the unit circle. Ooh. There we go. We add one full rotation around the unit circle, and that will take us to that positive amount. So negative 210 plus 360, bam, that gives us the 150 degrees. So now we can go to the positive 150 degrees, which is right here on the unit circle. And if we are looking for the cosine of 150, we want to find the x part of that coordinate, which would be negative rad 3/2. So negative. So note that once I find the cosine of 150, I don't have that cosine there anymore. Sometimes students will try to leave that cosine in front of this expression. When I evaluate the cosine of the angle, this is my final answer. And again, we can use our calculator simply to check ourselves. The cosine of 150 is something terribly nasty. The cosine of negative 210 is that same horrible nasty decimal. And if I do negative rad 3 divided by 2, ta-da! We get the exact same decimal as well. So again, your calculator can't get you to this exact radical answer, but it can help you check yourself to make sure you have done the problem correctly. So let's go ahead and move to number 3. Now this one is in radians. So 5 pi over 3 would be here on our unit circle. If I am looking for tangent of that angle, that means we want to find y over x. So remember, this is one of those concepts you have to have memorized. Cosine is x, sine is y, and tangent is y over x. So if I have 5 pi over 3, then the y value of that angle would be negative rad 3 over 2, and then divided by the x value of 1/2. Now that looks absolutely terrible because we've got a double fraction. So how do we resolve a double fraction? We resolve it by taking the fraction we're dividing by, which is the 1/2. How do I divide by a fraction? We change it to be multiplying by the reciprocal. So times 2 over 1. So now, negative rad 3 over 2 times 2 over 1, the 2's cross simplify with each other, and we're left with negative rad 3 over 1, or just negative rad 3. Now, if I wanted to use my calculator to check myself on this one, the first thing I would need to do is change the mode to be in radians, and then type in tangent 5, and your pi button is the second function of your caret button. So second caret, that gives me the pi, divided by 3. There's my terrible looking decimal. And if I type in rad 3 with a negative in front, we get that same decimal. So again, we can use our calculator to check ourselves, but it's not going to give us that exact radical answer that we want. So this is why the unit circle is better. So let's go ahead and look at number 4. Now this one is looking for secant of negative 3 pi over 4. So first, secant is a reciprocal trig function, and this one is the reciprocal of cosine. So reciprocal of cosine. So what we could do is find cosine and then reciprocalize it, or you can also think of it as the reciprocal of x, or 1 over x. So a couple of different ways to think about this problem, but ultimately we are looking for the same thing. Now, my angle is negative here, so we're kind of faced with the same issue that we had on number 2. You can either think about visually rotating by this same amount in the negative direction, which I personally find a little bit more challenging when you're dealing with radians, or we can find a positive coterminal angle. So we'll go ahead and try to visualize this first. 3 pi over 4 would be here. So if I rotated positive 3 pi over 4, I'd be in the middle of quadrant 2. If I rotated negative 3 pi over 4, we'd be in the middle down here at 5 pi over 4. So this is equivalent to secant of 5 pi over 4. Now, that is how we can visualize it, but we can also do the same thing that we did in this other problem, which is looking for a positive coterminal angle. So to find a positive coterminal angle for this one, I'm going to go ahead and just draw an arrow over. Instead of adding 360 degrees to find a positive coterminal angle when we are dealing with radians, we will add 2 pi. Now the gross thing about this is, can we just straight up add 2 pi to that fraction? We're going to have to find a common denominator. So 2 pi over 1, ta-da, now it's a fraction. But negative 3 pi over 4, we need to make these have the same denominator. So I'm going to multiply 2 pi over 1 times, I should have left a little bit more room here. I'm going to multiply that by 4 over 4 so that it has the same denominator as 3 pi over 4. So this now gives me 8 pi over 4, and then plus a negative or minus 3 pi over 4. And that gives me 5 pi over 4. So remember, find a common denominator and then your denominator stays the same, and you add your tops together. So we get the same angle that we got by visualizing it. So folks, it's totally up to you. The mathematical way of adding 2 pi and adding 360, that has other benefits, which we will see later with solving, but being able to visualize those angles is important as well. So I do encourage you to kind of try both of those methods as you start working through these problems. So now we can go to positive 5 pi over 4, which would be right there, down in quadrant 3. And first, we're going to look for the cosine of that angle, or the x value, which would be negative rad 2 over 2. Now, if I reciprocalize that, that gives me 2 over negative rad 2. Now, does it matter where we have that negative sign? No, you could have it with the 2 or down with the radical or just out in front of the fraction, but we do have a problem here. Does anyone see what the problem is? Hopefully the voice of Mr. Powell or Mr. Jones is resonating in your brain right now going, no! Can't be having that radical in the denominator. So we call this process rationalizing the denominator because currently we have something irrational there. And how you rationalize the denominator is you multiply by the radical that is messing that denominator up. So we're going to use our radical as a creative form of 1. So rad 2 over rad 2 is just 1. So I'm not changing the value of anything. We're just changing the way this fraction looks. So if I multiply straight across, that gives me 2 rad 2 over negative. Rad 2 times rad 2 is rad 4, and the square root of 4 is just 2. My final step is, now that we have this lovely rationalized fraction, we can cancel out those 2's with each other, leaving me with negative rad 2. So let's go ahead and check ourselves on this one, and I think this is important because it shows you that every single step of this gives us the same nasty little decimal. So first, secant of negative 3 pi over 4. So unfortunately, your calculator doesn't have a secant button, so we are going to have to find cosine of negative 3 pi over 4. And how do I reciprocalize that? We take 1 divided by that amount. So if I wanted to, I could take 1 over cosine of negative 3 pi over 4. And that gives me that nasty little decimal. Now, I can show that this is equal to the secant of 5 pi over 4 by doing 1 divided by cosine of 5 pi over 4. And ta-da, same nasty decimal. I can take this non-rationalized fraction, 2 divided by negative rad 2. I get the same terrible decimal. And my final simplified rationalized expression, we get the same decimal as well. So all of these answers are the same. So your calculator's not going to tell you whether you have rationalized it or not, but we can verify that all of these are equal to the same answer. So again, you can use your calculator to check yourselves, but again, there's no way for my calculator to generate that radical answer. So let's go ahead and actually, if I were you folks, I would go ahead and pause the video and try number 5 all on your own. So number 5, we've got a degree problem. So 270 degrees is right here. Sine of 270 degrees means we are looking for the y value of that angle. So ta-da! Our y value would be negative 1. And that's it. And if I went and changed the mode on my calculator back to degrees, we would see that sine of 270. Oh, awesome. So my calculator will give me sine, cosine, and tangent when it's equal to one of those nice values like 1/2, 1, or it's 0. So nice way of checking yourself on the old calculator. Now on the next problem, we encounter something different. We've got tangent of 3 pi. The problem with 3 pi is it's not on the unit circle. But why isn't it on the unit circle? So let's think of another example. 15 degrees. 15 degrees is not on the unit circle because it's in between the main angle measurements that we have shown. So 15 degrees, there's actually no way, well, not until next chapter, that we can mathematically use the unit circle to find it. But 3 pi, it's not that it's not a tick mark on the unit circle, it's that it's bigger than our unit circle goes. So how big does my unit circle go in terms of radians? It goes all the way up to 2 pi. This is more than 2 pi. So it's beyond the scope of our unit circle. So it's actually similar to what we did in number 2 and number 4, except instead of trying to find a positive coterminal angle, we're trying to find a coterminal angle that is within 1 rotation of the unit circle. So how are we going to do that? Instead of adding 2 pi or adding 360, we're going to subtract 2 pi from this. So if I subtract 2 pi, we get tangent of pi, and tangent is y over x. So we go to pi, which is here. Y over x would be 0 over -1. And sometimes students get stumped on this. It's like, oh, is this undefined or is it 0? You can divide 0 into as many equal parts as you want. It would just be equal to 0. It's only having 0 in the denominator that is undefined. And we will encounter that on some of these problems, I believe. So that gives me 0. Now, lucky for us, if we change our calculator to radians, we can check ourselves on this problem. The tangent of 3 pi is equal to 0, so the original. The tangent of pi, that coterminal angle within the scope of the unit circle, is 0, and that shows that that is what the tangent of 3 pi is equal to. All right, folks, so moving on to number 7, we've got the cosecant of 11 pi divided by 2. So 11 pi over 2, it's not on the unit circle. Excuse me, but why is it not on the unit circle? It's because this is, again, more than 2 pi. Now, if you're like, Mrs. Caro, how do I know that that's more than 2 pi? We can just think about this in terms of a decimal. 11 halves is the same as 5.5 pi. And 5.5 pi is beyond the 2 pi that our unit circle shows us. So we are going to have to subtract 2 pi until we find something that is within the 2 pi radians of the unit circle. So I'm going to subtract 2 pi. And notice that I'm just going to leave it in the decimal because, yeah, if I don't have to mess around with those common denominators, I'd really rather not. So we subtract 2 pi once, and we get cosecant of 3.5 pi. Yep, that's still beyond the scope of our unit circle. So we subtract 2 pi again. And that gives us cosecant of 1.5 pi. Ta-da! So that is the same as the cosecant of 1.5 is 3 pi over 2. So 3 pi over 2, that is on the unit circle. That's going to be this guy right here. So cosecant, remember, is the reciprocal of sine. So sometimes that gets confusing. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So you think the cosine goes with cosecant, but it's actually flipped around. So sine with cosecant and cosine with secant. So this is the reciprocal of sine, which means we are looking for the reciprocal of y in the coordinate, or 1 over y. So if I reciprocalize sine, sine of 3 pi over 2 is -1. So what happens if I reciprocalize -1? Well, if I have negative 1 over 1, and we reciprocalize it, we get 1 over negative 1, or just negative 1. So you can reciprocalize the fraction or take 1 divided by that value. Either will give you that reciprocalized value, and that is what cosecant is equal to. And we could check ourselves on our calculator on this one as well. All right, folks, last problem of the unit. We've got cotangent of negative pi. So visualizing this one, if I rotated positive pi, that would take me to here. If I rotate negative pi, it takes me to that exact same place. So cotangent of negative pi is the same as cotangent of pi. That is how we can visualize that. Or I can change that negative angle to a positive coterminal angle by adding 2 pi to it. So if I added 2 pi minus pi would also give me pi. So that gives me a positive number on the unit circle. Now, cotangent is the reciprocal of tangent. So that means instead of y over x, we will have x over y, the reciprocal of that tangent value. So if I look at pi, its x value is negative 1, and its y value is 0. Uh-oh. So negative 1 divided by 0 is undefined, or you can say DNE, for it does not exist. And folks, just to show you that you could check yourself on your calculator for this one, I would need to do 1 divided by the tangent of negative pi. Ooh, and I should probably check my mode. Yep, I am in radians. Good for me. So 1 over tangent of negative pi, we get error dividing by 0. So that shows us on our calculator that it is also undefined. So folks, that closes off Unit 8 for us, but I just want to show you the things that we are not covering in this chapter, because if you wanted to print this off from the note packet key, this is not a bad thing to have as reference for Calc 1. Definitely not a bad thing to have as reference for the ACT. The first thing that you will not need to know for pre-calc, but you will need to know later on, is the law of sines. This does come up on the ACT, and the law of sines is just something you can use on any triangle versus any right triangle, like SOHCAHTOA. So law of sines, you can set up as this happy little proportion. That's as far into that as I'm going to go. And there's story problems in here. The rest of the chapter is solving triangles, the ambiguous case, the good old SSA case, which you probably remember from Trig. And then lastly, the law of cosines. The law of cosines, I would say it comes up maybe like every 4th time on the ACT. It doesn't come up very often. It's very rare when it does. It's a bear of a formula to memorize. It's a bear of a formula to use. But if you want to look at the notes on this, I do have some tips and tricks on how to memorize that. So again, just to clarify, folks, in this chapter, for pre-calc, our class, you will only be expected to know up through page 5. But if you wanted to print off the rest of the notes to have for your future reference or for ACT stuff, those notes on law of sines and law of cosines are all available to you. So excellent work. And next week, we will be starting our final unit, or Unit 9.